Hello, everybody. Here's our guide on forensic body examination, Mortis and blood evidence. So first, there are six contents to overview. Introduction to Mortis, types of Mortis, examining the body, blood stains as evidence, putting it all together, and conclusion and key takeaways. So here's an introduction to Mortis. Mortis is changes after death. It helps to estimate the PMI, the post-mortem interval. There are four key types to remember: pallor, algor, rigor, and livor. First, we have pallor mortis. Pallor mortis is when the skin becomes pale in color. It normally has more of a gray appearance. Algor mortis is the cooling stage, and rigor mortis is when the muscles start to stiffen, and then livor mortis is when the skin becomes more dark purple in color due to oxygen dissociation. This is common in dead bodies. Pallor mortis is the paleness of death. It occurs within 15 to 30 minutes, and it's usually obvious in and seen in the face, lips, and skin as there's a bit of dryness. It's useful only in very early deaths, and additionally, the eyes already have a thin layer of corneal clouding. As you can see, the image shows the different stages of the eye as it undergoes through tremendous amounts of hours, and as it is increasing, the eye continues to degrade in its discoloration of its cornea. Algor mortis. Algor mortis is the coldness of the and cooling of the body after death to ambient temperature. This process is the propensity of a body to reach equilibrium with ambient temperature after death. It is the cooling of the body, it falls towards room temperature, 1 to 1.5 Celsius per hour in the first 12 hours, and faster in cold rooms, slower if cloth, tested with thermometers on the rectal or liver. And then there are factors that affect the rate of cooling, like environmental temperature, body composition, clothes and coverings, body position and exposure, surface contact, humidity, and age. Algor mortis has a bunch of formulas for the PMI estimation, such as the Glaser equation. The Glaser equation estimates the PMI based solely on algor mortis. The equation is expressed as PMI is equals to 98.7 Fahrenheit minus rectal temperature of the dissident. So where T is equals to 1.5 if ambient temperature is less than 32 Fahrenheit, or T is equals to 0.75 if ambient temperature is greater than or equal to 32 Fahrenheit. This formula assumes an approximate cooling rate of 1.5 Fahrenheit per hour under typical conditions. A person's body is found and the rectal temperature is measured at 90.7 Fahrenheit. As you can see, we will use the second one, which involves 0.75. So, as the room temperature is 70 Fahrenheit, we plug into the Glaser equation 98.7 minus 90.7 divided by 0.75. And as you solve the equation, you'll get 10.67 hours. The person likely died about 10 to 11 hours ago. And that's how you use the Glaser equation. Continuing, we will now discuss the second method, the Henschke nomogram. Hensch nomogram is the most precise method for estimating the PMI by measuring temperature. This method is most accurate within the first 10 hours post-mortem. To use the Hensch nomogram to estimate the time of death, plot the body's rectal temperature and the ambient temperature and form and connect a line. So basically, imagine this as a blue colored line where you place it at here at 25 between 30 at the top left. Look at this. Okay, it's like a ruler, and then there you go. You put your point here, and then you stretch it out towards here to the very far lower right. This is the ambient temperature, which is 15 Celsius. And as you can see, there's now a huge line, a blue line. And then afterwards, you're going to use the two intersecting lines as a reference point, and then place your place your cursor at the central circle. And then all you have to do is form a central line that targets the diagonal. So as you can see, it will target the diagonal and reach out to the end point. After which, take into account the weight of the body along with the clothing. Moving air can also affect the body. This is known as the corrective factor. Anyways, in the image at the right, the corrective factor is known to be 1.3. So if you were to calculate this, it would be 70 kilograms multiplied by 1.3, which is equals to 90 kilograms as the corrected body weight. And as you can see, you first place your cursor at 90, and then you follow the line until it reaches to the line that which the central circle had hit. So as you can see, imagine this as a red line, okay? And then as it hits the point which also hit the 90 kilogram body weight, this would be an important reference point on the kilogram axis. And this will give you the estimated time of death. For this one, it would be between 16 to 18, or roughly and specifically 17.2. So this is 17.2, and using corrective factors, it will have plus and minus 2.8 hours as the central line roughly like hit the 2.8 hour mark in corrective factor part, as you can see. So yeah, that's all I have to explain in regards to the Hench nomogram. It's pretty useful in determining the exact time of death, roughly 10 hours post-mortem. Now we have rigor mortis. Rigor mortis involves the muscle stiffening as ATP is lost. It starts between 2 to 4 hours, and it fully stiffens the body at 6 to 12 hours, and it fades after 24 to 48 hours. It all begins in the jaw, and this spreads to the limbs. The jaw muscles, or the masseter, is easiest to test early on. After that, the jaw is usually the first place where stiffness appears. In forensics, jaw muscle stiffening from rigor mortis is confirmed by attempting to manually move the jaw shortly after death. Neck muscles, these also stiffen early along with the jaw. Limbs, the arms and the legs, stiffness then spreads downwards to the arms and legs. And about 12 hours after death, most muscles are stiff. So here's a timeline. So between 0 to 2 hours, there is no stiffness yet, so the muscles are still soft. Between 2 to 4 hours, the jaw and neck muscles start to stiffen. 48 hours, the stiffness spreads to the upper body, the arms, shoulders, and chest. 8 to 12 hours, the stiffness finally reaches the legs and full body, where rigor mortis is complete. 12 to 24 hours, the full body remains stiff, and 24 to 36 hours, the stiffness fades in the same order. And greater than 36 hours, the rigor mortis is gone, the muscles relax again due to decomposition. Now, livor mortis. Livor mortis is the reddish blue to the purple discoloration of the skin that occurs after death due to blood pooling in the lowest lying parts of the body by gravity. As the heart stops circulating it, the blood settles at the lowest point of the body. The purple red discoloration of the skin, it starts at 30 minutes to 2 hours, and it is fixed after 6 to 12 hours. If you noticed it, livor mortis and rigor mortis are overlapping in its factors, as they both involve the stiffening and the discoloration of the body, which is quite normal as it is one of the factors in determining the death of an individual. Anyways, it is forensic importance to know the time of death, the body movement, and the cause of death. using the factors indicated in Liber Mortis. In regards to equations, Fowler Mortis has no equations because it's so fast, forensic scientists don't really use it to calculate the PMI. It starts within 15 to 30 minutes after death. Algor Mortis has equations like the Glaister and Henge. It can give the rough PMI in the first day, but it is highly variable. It is useful for about the first 24 hours and it overlaps with rigor and livor. Rigor and livor mortis has no equations. It is involved with stages and time frames. Both overlap with each other in 2 hours. In rigor, good medium term indicator from hours to a day, it begins 2 to 4 hours after death, the jaw and neck. It completes to 12 hours, starts to fade at 24 hours, and is gone at 36-hour mark. Livor mortis shows the body position after death. If moved, lividity patterns can reveal it. It is starts at 20 minutes to 2 hours, visible to 2 to 4 hours, becomes fixed at 6 to 12 hours, and after 12, pattern is permanent. Examining the body. What to do first? First, keeps the scene safe and don't move the body. Call trained personnel. Wear gloves and PPE. If you must be near the body. And document the time found and who is present. Write it down. Mario Annabelle time found 6:30 p.m. Present are the deceased's spouse and parents. What to check and record. Color changes. Father and liver. Note where the red and purple is and whether it is fixed. And the stiffness of the body. Checking the jaw, the neck, the arms, the legs. Right? None, partial, or full. And then the body temperature, record where you measured it. Rectal is preferred, the temperature and the time. And then the clothing covering, wetness and positions of the body, and any visible injuries or marks. Documentation. You must document the scene, taking photos of the injuries and noting the time, temperature, ambient temperature, witness statements, and then cross-check the and compare the algorithm, rigor, stiffness, and livor, and give the PMI as a range, not an exact hour. Bloodstain basics. There is a bunch of points that you need to know. Firstly, there is the fresh blood, which is bright red, wet, and sticky. 1 to 3 hours, this should become darker red and tacky. Fully dried, brown or black, rigid and flaky. And then we have the touch test, which is wet, tacky, dry, and powdery. And you can tell if it's tacky, if it sticks to your finger, wet if it's quite fresh, and then dry and powdery if it simply is quite flaky in how it is handling your finger when it is touching it. Anyways, the drying speed depends on surface and weather. There's a size, shape, and clues regarding blood stains. In round drops, it fell straight down. In elongated drops, it is a blood in motion. So it has an angled impact. In pooling, there's large puddles that dry from the outside, and then inward, edges may be dry while the center is still wet. Rehydration test. Dried stains can look fresh again if exposed to water or humidity. And then the environment matters in regards to the blood stain. It has a faster drying in hot environments and slower drying in cold environments. As you can see, the high impact has the size of the drops are less than 1 millimeter, and the velocity would be 100 feet per second for a gunshot blood splatter. And then there's the medium impact and the low impact. And as you can see, this is a 90 degrees with no direction. The spine connect with the main blood droplet and the satellite are the small secondary droplets. Blood stains and its equation. There is no drying blood equations. They do not exist. That is more of an observation. What this focuses more on is the angle of the blood stain, the angle of the impact specifically. So it's used to find the angle at which the blood hit a surface. You use angle equals arcsine width over length and the short axis of the droplet and the long axis of the droplet. And as you use this equation, you will also combine the points regarding the point of convergence and the point of origin. And both has its respective points, and it's used for determining the crime scene and and where the blood originated from. So these are the blood stain and visuals. As you can see, this is fresh blood, and then as coagulation occurs and then finishes at center desiccation, the blood becomes drier, as you can see. Anyways, tacky blood occurs usually between 1 to 3 hours, and dry blood occurs between 3 hours. But as it is said, drying time grows with the square root of drop size. But in real cases, there are too many factors like humidity and surface type. That's why investigators stick to simple wet, tacky, dry stages instead of math formulas. Anyways, estimating the PMI using all the clues. Okay, so first there's the signs. Rigor mortis, partial, 8 hours. So liver mortis is fixed. And then the blood stains, dry, dark brown, and then algor mortis, body cooler than normal. So interpretation, each clue alone only gives a rough range. Together they narrow down the PMI. So in rigor, it's 8 hours. In livor, it's 6 to 12 hours. When the blood dried, it's like 3 plus hours. And as you combine all the information, it's consistent with the 8 to 12 hours since death mark. So the most accurate PMI estimates come from combining multiple signs, not one test alone. And this would be even more specific if weight was involved. So in conclusion, mortis is equals to natural post-mortem changes, pallor, algor, rigor, and livor. Bloodstains add context of wet, tacky, and dry used in investigations with other signs, and then combine the multiple signs and give PMI as a range. And then remember to keep the practices and maintain the body at the condition as it is under professional standards. Remember the safety and procedures and limitations regarding the change in temperature, humidity, clothing of the room. And then the final line, forensics equals careful observation plus scientific context. So these signs give useful clues, but none are perfect alone. By checking the pallor, body temperature, rigidity, lividity, and the blood evidence together and noting environmental factors, we can make a safer PMI estimate and know when to hand the case to specialists. So that's all. That's how you use forensic science in regards to mortis and bloodstains.